Every night, we see stars sparkling in the sky, but most people rarely stop to consider their age and distance from the universe. Some stars, for example, were born at the same time as the universe and, despite their seeming strangeness, are just as bright as younger ones. Hello, and welcome to Z. Please don't forget to subscribe and hit the bell icon. According to scientific estimates, our universe is roughly 13.8 billion years old, which is quite impressive when compared to the age of the Earth, which is only 4.5 billion years old. I wonder if you've heard of the Methuselah star, also known as HD 140283, and what makes it so extraordinary that scientists believe it to be over 14 billion years old. That's where. For more than a century, astronomers have been observing a strange star in the constellation Libra that is located 190 light-years away from Earth. It travels at a speed of approximately 1.3 million kilometers per hour, but what makes it so strange is its age. The universe is over 13.8 billion years old. So how can it possibly contain a star older than itself? When scientists attempted to estimate the age of HD 140283, one of the oldest stars in the universe known to science, in 2000, they were guided by data gathered by the European Space Agency's Hipparcos satellite, which launched in that year. As a result, they came up with an estimate of 16 billion years. The universe was proven by observations to be 13.8 billion years old, which was the generally accepted age. There was much discussion on how a star could be older than the universe, or else due to the disparity between the two quantities. The universe appears to be younger than a star. The star's unusual name, Methuselah, was inspired by the biblical figure who lived to 969 years in Scripture. The star is undoubtedly very old. It is a subgiant that primarily consists of hydrogen and helium with very little iron, suggesting that it formed before iron became a common element. However, how a star can be approximately 2 billion years older than the environment it lives in seems to be a bewildering paradox. In order to confirm the star's age, astronomer Howard Bond and his colleagues at Pennsylvania State University had to go through 11 observational datasets that the Hubble Space Telescope's fine guidance sensors had gathered between 2003 and 2011. They were also struck by the fact that Methuselah had been born before the universe. The sensors calculate radiation energy and star locations and distances. According to Bond, determining an object's age can be achieved with accuracy by analyzing its parallax and applying spectroscopy and photometry. However, since the exact distance to HD 140283 was unknown, this could have led to an inaccurate age estimate. Therefore, the distances needed to be carefully measured in order to calculate the object's luminosity and determine its age. The brighter the star, the younger it is. A year was spent by the scientists monitoring the star's location in the sky and researching parallax. The team thought about the possibility of a faster thermonuclear synthesis because theoretical models also left a lot to be desired. The scientists were unsure of the precise rate of nuclear reactions and couldn't pinpoint the role of the diffusion of certain elements in the star's outer layers. This was another piece of evidence supporting Methuselah's younger age. Eventually, the value that Bond and his colleagues produced was 14.46 billion years, plus or minus 800 million years. This is obviously less than 16 billion, but still more than the age of the universe if the star really burned faster than average ones do. Bond also added that oxygen at HD 140283 also had to be reckoned with. The ratio of oxygen to iron was rather high, and in the first millions of years of the universe's evolution, there wasn't that much oxygen around. A British physicist from Aston University in Birmingham who was not part of the research team, Robert Matthews, claims that the estimations could have been tainted by both unintentional and intentional mistakes. The universe's age, determined through relic radiation, disagreed with the most recent, accurate estimate of the star's age. This discrepancy could only be reconciled by allowing for a greater margin of error in the conclusion. The star's age was later determined to be even younger in 2014. In a study titled Sequel, The authors estimated that Methuselah lived for 14.27 billion years, though they acknowledged that there was still a 7.800 million year margin of error. Oddly, the star's age exceeded that of the universe, according to Bond. The similarity between the values of the universe's age and its oldest star supports the consistency of the Big Bang Theory, in addition to the fact that the values were derived from various techniques of analysis. Because of careful observations when ancient stars were estimated to be 19 or even 20 billion years old in the 1990s, the results were more erratic, at least at that time. The errors did not conflict with the widely accepted models. Robert Matthews, however, insists that the problem is far from resolved. In July 2019, for example, scientists attended an international cosmology conference at the Calvary Institute for Theoretical Physics in Santa Barbara, California, where they examined studies of the universe's estimated age. Based on the galaxy nearest to us, the universe is several hundred million years younger than indicated by the results of relict radiation calculations. For all we know, our universe may only be 11.4 billion years old. Nevertheless, the new estimates shouldn't be dismissed with abandon, as one of the authors was Nobel Prize-winning astrophysicist Adam Rees from the Space Telescope Science Institute. Conclusions are drawn from Edwin Hubble's 1929 theory of the universe's expansion. The rate of expansion is actually 10% higher than suggested by Planck's team. The rate of the universe's expansion is 67.4 kilometers per second per megapascal, but the latest measurements yield a value of approximately 73.74 kilometers per second per megapascal. The expansion of the universe is a fundamental concept in the Big Bang Theory. If the universe has always been expanding, shouldn't there be a starting point for the process that could be calculated? According to Rees, there ought to be a discrepancy between the expansion pace that is actually occurring right now and the rate that the early universe's physics suggests. First, it is clear that current ideas need to be carefully questioned. Secondly, there is the mystery surrounding dark matter and dark energy, which suggests that the universe may be younger than we think because the Hubble constant yields a larger number for the rate of expansion. The age of 13.8 billion years is represented by the constant 67.74, while the age of no more than 12.7 billion years is represented by the constants 73 or even 77. The Hubble constant is said to be 82.4, according to a recent study published in a reputable science magazine. In any case, the star HD 140283 still looks to be older than the universe. For context, the magazine is called Science. Matthews believes this is a task to be handled by cosmologists rather than astrophysicists to define the age. Precisely, it isn't stars that have to be studied but more complex structures of the universe. So why would the universe appear younger than this one star? Matthews suggests at least two possible explanations. As is so often the case with the history of science, the end result is likely to turn out to be a combination of the two versions. In short, there may be observation errors caused by something we do not fully understand, and there may also be some blanks in our knowledge of the universe's dynamics. For example, the dark matter force, which has been in charge of the expansion of the universe for billions of years, is still rather baffling to us. Thus, the age paradox could well be accounted for by dark energy variations and changes in the expansion rate, according to theorists. All this may have to do with the fundamentals of the nature of gravity, in particular the causal set theory, which leads us to believe that by measuring gravitational waves, we may get to the bottom of the paradox. Gravitational waves are hard to measure. Just to give you an idea, they were first detected as recently as in 2015. We can access a lot of information about space objects, astronomy discoveries, and the studies of well-known scientists. It is within our power to share this information and bring as many curious minds up to date as possible. If you are as impressed by such discoveries and incredible facts, please share this video with friends or simply hit the like or bell button. Astrophysicist Stephen Feeney of the Flatiron Institute believes that a major scientific breakthrough on this front may take place in the next 1,000 years. The bizarre phenomenon of the age of HD 140283 is bound to reveal larger and more scientifically complex things that are yet to be discovered and explored. Let's stay in communication.